Section 2.3D2 part 2 deals with what happens when it's not a square matrix. And what I mean by square is to the left of that bar, the rows and columns are the same amount. So overdetermined refers to what happens when the number of equations is larger than the number of variables. So number of equations is larger than the number of variables. So in this case, you would have 3 equations, but still only x's and y's. And the same is true in this case. You'll notice you've got 3 equations, but still only x's and y's. So more equations than variables. So there's 2 possibilities that are going to happen here in terms of what's going on. You'll notice that in both of these examples, I have a row of all zeros. Both of these are straight from the handout. Well, what happens here when the row of all zeros occurs is I'm going to backtrack to what's right above it and notice that I do have something that is going on. If I ignore the bottom row, this is a single solution. How do I know it's a single solution? Because the top row tells me that x is equal to 2. The next row is telling me that y equals 4. I have an answer for x, I have an answer for y. I know specifically that is the point in space where they cross. So even though I have a row of all 0, that extra equation is not adding anything to where these 2 are crossing. What's really going on here is this bottom equation is probably identical or the same line as one of the other 2. So you have 3 lines, 2 are the same, and they're crossing with the other one. Now, the other case, yes, indeed, I have a row of all zeros, but notice I also have a row of zeros here. So there's no way for me to narrow down that single point where these things are all crossing. So again, the row of zeros is telling me it's an infinite solution. Because these are x's and y's, we're going to go to the parameter and let y equal t. So I know that x plus 2t is equal to 3. So x is equal to 3 minus 2t. So you can see the infinite solution sitting there in terms of t. What happens if we flip this and have equations that are less than the number of variables? So the equations, a smaller number of equations than you have variables. So the example on the board literally has just 1 equation. Well, there's no way you can solve that. There is no way you can find one specific answer to that. So automatically, this is an infinite solution case, depending on what you get for x and y. So infinite, even though it does not have a row of zeros, it's an infinite solution. You would go to your parameters again. So we're going to let y equal t. I think this is the same as this line. So this would be x plus 2t equals 3. So x is 3 minus 2t. And again, we still get that 3 minus 2t, comma t. Now, anytime you have a row of zeros equal to a constant, it's a no solution here. So anytime that occurs, you know it's a no solution. So those are our overdetermined and our underdetermined. Let's do some examples and show you how they pop out as we're solving some systems. So that's kind of like the background information. Let's go solve 2 more. Okay, so our first one is our example has 3x minus 2y is equal to 5. We also have negative x plus 3y is equal to negative 4. And we have 2x minus 4y is equal to 6. So let's go write it as our augmented matrix and then come in and solve it. Notice that we have 3 equations. So the number of equations is larger than the number of variables. Okay, so automatically I think goofy stuff's going to happen. When I go to do this one, you can do it a number of different ways. Let's do something we haven't done yet. Let's go ahead and copy it over the way it is. You know, every time I've been going for the 1, I've been multiplying that row by a fraction to create the 1, but you can actually subtract and create the 1 that way too. It's not my preferred method, but it does work. And I wanted to show it to you one time just so you can see it. So what I'm going to do to get the 1 here is I'm going to come in and take row 1 and subtract row 3, because that would be this 3 minus this 2, which is going to give me my 1. So row 3. So that'll give me a 1. Negative 2 minus a minus 1 would be negative 1. That's 5 minus 6, which is also a negative 1. I'm going to copy everything else over. Okay, now we need our 0. So I need this to be a 0, and I'm going to go for this as a 0 also, just to make that the unit column that we're used to seeing. So we'll do row what? Row 2 plus row 1 to get that as a 0. So we have our 1, negative 1, negative 1. Negative 1 plus 1 is 0. 3 minus the 1 is 2. And negative 4 plus, and the negative 1 is going to give me a negative 5. Oop, that was hard to say. Okay, now we're going to come in and take row 3 minus 2 times row 1. So row 3 minus 2 times row 1. So that's this one minus 2 times that one. So that gives me my 0. I have a negative 1 minus 2 times a negative 1. That's going to make that a positive 2. So that's a 1. We have 6 minus 2 times negative 1. So 6 plus 2 is going to give me an 8. So far, so good. We now need the one right here. Again, I'm working off the diagonal. I'm looking at my diagonal, recognizing I run into problems with the diagonal, but that's because it's more equations and variables. Let's go get the one where we need it. So we're going to come in and multiply by a half. Negative 1, negative 1, I have 0, 1, negative 5 halves. And then we have 0, 1, and 8. Okay, now we're going to put a 0 here and a 0 here. And something doesn't look like it's working out correctly, but we'll go for it and see what happens. So to get the 0 here, we're just going to add these two rows together. So we're going to take row 1 plus row 2. So that would be 1. Negative 1 and 1 is 0. Negative 1 and 8. Negative 1 and 8 is 7. Next row's fine. It is. Last row, we need to manipulate it. So we'll take row 3 minus row 2. So row 3 minus row 2. So 0 minus 0. 1 minus 1. And 8 minus 5 halves. So 8 minus 5, minus a minus 5 halves is going to make that a plus 5 halves. That's 16 halves plus 5 halves would be 21 halves. And we have messed up somewhere because I show that we should get a row of all zeros. So I do apologize because somewhere, oh, you guys are probably screaming at me. I miscopied all the way back up here, but it goes to show you how careful you need to be. So this negative 4, I wrote as a negative 1. So let's see if we can trace that through and show you how obnoxious this is to trace through. So it doesn't change the first manipulation because we just, oh, no, it does. Because it's row 1 minus row 3. So that would be this negative 2 minus this minus 4, which makes that a plus 4. And that's going to make that a 2. And at that point, I'm going to start all over. It just goes to show you that all of us can make mistakes. You guys were probably screaming at me to not do that. Don't mess up from the beginning. Okay, so 3 minus 2 gives us a 1. Negative 2 minus that minus 4 is going to make that a positive 2. 5 minus the 6 is still the negative 1. We're copying everything else over. And you'll notice because we manipulated that one first, every time we refer back to row 1, the answer would have changed. So it's just easiest to erase and start over. Let's go for our zeros. So we're going to do row 2 plus row 1. So row 2 plus row 1. We have 1 and negative 1. Hang on, let me copy. So 1 and the negative 1 is 0. 3 plus 2 gives me a 5. Negative 4 plus that negative 1 is going to give me a negative 5. That feels so much better. No fraction coming in. Okay, to get this guy to be our 0, we're going to do row 3 minus 2 times row 1. So 2 minus 2 is going to give me a 0. Negative 4 minus 2 times 2. Negative 4 minus 2 times 2 is going to give me, unless I messed my signs up someplace, just double checking to make sure. Yeah, it's going to give me what, 8? And then we have 6 minus 2 times negative 1, which is also going to give me 8. So I'm feeling pretty good about that. All right. Okay, much better. Okay, now we're going to come in and get the 0 here. To do that, we're just going to do 1/5 of row 2. So 1, 2, -1, 0, 1, -1, 0, 8, 8, and so forth. Okay, I'm going to go for the 0 down here first. Normally I wouldn't do that, but because I have more equations than I do variables, that bottom row is going to dictate what kind of answers I get. So I'm going to go for it first. Or I'm just going to do row 3 minus 8 times row 1. Nope, row 2. You always manipulate the row or multiply the row that has the 1. So row 2. So that's going to give us 1, 2, -1, 0, 1, -1. Okay, 0 minus 0, 8 minus 8, and 8 plus 8, 8 minus 8. You should get another 0. So yeah, somewhere I have another sign error floating around. Does anybody see where it happened? I don't see where it happened. Row 3, -4, right there. Row 3 minus 2, -8, -8 plus, and that gives me 0. So there it is. Phew, that was long. Sorry about that. Okay, that row of zeros tells me I run into problems. So this tells me it's an infinite solution. Specifically because I don't have what I need up top, because this equation still has zeros floating around in it. We're going to come in and we know that. Wait, is it an infinite solution or not? Hang on. What do you think? So y is equal to a -1. And if I put y in up here, then we would get x equal to something too. So it's not an infinite solution. So watch for those snap calls. So just because we have a row of zeros doesn't mean we're done here. Let's go ahead and put the 0 here just for practice. So let's do row 1 minus 2 times row 2 and see what falls out of this. So 1 minus 0 is 1. 2 minus 2 is 0, which is great. -1 minus that so it'd be -1 plus 2 is going to give me a 1. So 0, 1, -1, 0, 0, 0. Okay, so I know I have a row of all zeros, so I ignore it for a minute, backtrack up, and because I have just an x and just a y, I know it's a single solution. So I get just a single answer, x equals 1, y equals a -1. Not an infinite solution. Let's go do a different one. It was a little rough, sorry about that. But at least you can see that it's so easy to make sign errors and it's so easy to make copying errors. I can almost say I did it on purpose, right? One more example and we'll call it good for this section. So now we're going to do more variables than equations. So an underdetermined one. So this is our last example. We have 4x plus y minus z is equal to 4. We have 8x plus 2y minus 2z is equal to 8. So we already know we're in trouble. So it's either going to be a no solution or an infinite solution because I don't have enough equations to peg down a single spot where these two planes cross. So I automatically know it's going to be an infinite solution or a no solution. I just have to figure out which one it is. So let's go ahead and write them down. So we have 4, 1, -1, 4. We have 8, 2, -2, and 8. Okay, we're going to come in and multiply this by 1/4. So 1/4 for 1. It's going to give me my 1. It's going to give me a 1/4, a -1/4, and a 1. 8, 2, -2, and 8. Okay, we now need a 0 where this 8 is. So we're going to take row 2 minus 8 times row 1. See what happens. So that's 1, 1/4, -1/4, and 1. So 8 minus 8 gives me 0. I have 2 minus 8 times 1/4. Well, 4 goes into 8. 2 times 2 minus 2 gives me a 0. In the next spot, we have -2 minus 8 gives a -1/4. That's going to make that a positive 2 plus 2 is 0. And then we have 8 minus 8 times 1, which is 0. So there's the row of all zeros sitting there. Everybody feel good? Okay, so because it's a row of all zeros, and I then look at the row right above it and recognize that I don't have enough information to tell me what X is or Y or Z because there are no other zeros working in my favor. So I know it's an infinite solution. The difficulty is if I come in and let Y, Z equal T. So if I come into this top equation and replace that with a T, I still have X's and Y's. There's no way to solve for X without a Y or solve for a Y without an X. So unfortunately, I have to pick a second parameter in order to write this system. So we're also going to let Y, the next to last letter we're using, equal S because S and T go together. So now I'm going to take my top equation. That's the 4X. In place of the Y, I'm going to write an S. In place of the T, we're going to write, in place of the Z, we're going to write a T. And we'll get the 4. And now we're just going to solve it for X. So we're going to say 4X is equal to 4 plus T minus S. So X is equal to 4 plus T minus S all over 4. That's an ugly way to write that. Okay, so our solution is 4 plus T minus S all over 4, comma, the Y value we're going to pick is S, and the T value, Z value is T. And what this means is if you're to find a point that is a solution, you have to not only pick a T, but you also have to pick an S. So you might pick 1, you might pick the 0, and then plug it in and see what happens, and you'll get an answer for X. So it's an infinite number of solutions. Again, the reason is it's not just the row of all zeros, but the fact that when I come back up to the row above it, I don't have enough information to give me an X value, a Y value, and a Z value at specific points. So, and that wraps up chapter 2 for us. There are more sections in there, but we do not do them in this class. So.